So as I said, like I'll be talking about Hawkeye. So it's one project I developed at CBS Interactive for automating some workflow that we needed, some real use case we found for that. So I'll talk a bit about that. Who am I? So I'm Rafael Caricio. As I said, I work for the video technology group for like CBS, Viacom CBS Digital. You can find me in diverse social media, just Rafael Caricio everywhere. Just a little bit about my background. Like I work with software development for like about 15 years, but it's the first time I'm actually working with video processing. So it's very interesting. It's a very interesting move for me. So I'm very happy to be here. And I joined CBS Interactive like 3 months ago. So I'm really new in this community and I'm very happy to be joining. Uh, just a bit of background. CBS Interactive is like contains a bunch of other brands that you might have heard about, have used some of these websites. Like they are like digital content. So I work in the video live streaming squad. So we support, like we develop platform that support those brands, not only of the CBS but also Viacom, which is the broader um, company that we are one of them. So yeah, we provide the live streaming services that any of those brands can use to do live stream online. So the main project of the team that I work on in at CBS Interactive is Propeller. So this is our logo. Basically, the Propeller project is a vendor agnostic live stream platform that we use for creating, provisioning many different services that are cloud based. So from partners like AWS, but also like internal services that we have developed internally, like Mood CDN, Encoding on demand that we have. And this project is basically used for like ad hoc live stream and also linear channels online. Um, so today we'll be seeing how we expanded or how we could expand the functionality of Propeller to solve this problem that we had. So what's the problem, right? Like what we are trying to solve here? What trigger us to create this Hawkeye project? So the problem that we had is that we started like broadcasting the UEFA games. Maybe you heard about that. So there are multiple games happening at the same time. In this case, we don't have like editing for all the videos, all the different streams that happen at the same time. Um, so we don't have like SCSI 35 tags, or we don't have information about when the ad is going to start or how long the ad is going to be. Um, but what we could see is that the channels that like those different channels when they have some slot that could be used for ads, it's just like a static slate saying, "Hey, we are going to be back soon." So one way that we could make use of these uh, parts of the video that there is just this slate um, for ad insertion would basically allocate people, like multiple people at this working and online watching the stream, and coordinate this via manual triggering. So in Propeller there is like a button there that if you create a channel that supports ads, you can just go there and press like trigger ad now, and then the ad is going to start like playing in the stream. But as you can imagine, this is like a lot of manual work, is expensive, and it's error prone. Like people can forget or can miss when they should press to trigger the ad. So there is a few. We thought that we could make it better and maybe find a different solution for this. The solution is basically automation, right? So how can we automate this process of checking that there is a slate and then triggering ads. So yeah, automation for the rescue. So we decided like we could create an application that's capable to of watching the live stream, and then when see like okay, this is our slate, trigger the automatic ad. So basically we had this button right in the UI, so we have this API that we could call to trigger the ads. But then now we think, okay, how can we develop this application? So what we needed to make this usable is that it needs to be first and foremost like really fast. So we cannot just have something that will take a long time to figure out that there is a slate in the video stream. So we need this to be really fast. This needs to be in real time with the video and checking if there is a slate. Um, and then it has to support multiple streams. As I said, we had multiple different streams, and that's the whole point that we wanted to develop this tool. So we needed to be somehow scalable, right? So we can have one, two, three multiple streams at the same time with different slate images that could be in every stream could have different slate images. Because we are talking here like this was triggered by the web games, but which there is one specific slate may be there, and then there is another game or there is another different kind of programming that have a different slate. So we need this flexibility, and not only in the image, the slate, but also how we trigger the ads. At the time we started, we didn't know like where we would exactly trigger the ads because we have this API call to trigger the ads via this HTTP REST API, but we needed to be more flexible as well there to maybe we needed to trigger ads in a different place, so or we didn't know basically where we could trigger the ads. So we need some flexibility there so the project is more like there is a broader usage for this. So let's talk a little bit about the implementation of this project, like what have worked for us. So we pick up some technology that we already had on plate or that we already knew. I was allocated to work in this project. I had a lot of time to work on it, but I had to come up with a solution for that. So for me, okay, I'm holding on technology that I already know. So the technology I choose for this project with the team was we would use GStreamer, right? Like GStreamer is very well known framework for video processing things. And then I already knew Rust programming language is a compiled fast programming language, not resource hungry, have a low memory footprint, right? Like just what we actually are needed, and it's yeah basically native. It compares to native code, so it's really fast. And another technology I have used before and that we had available already, like we had our Kubernetes cluster, and Kubernetes provides this very great API, right, for provisioning services on demand and scaling. So we could, yeah, make use of this API to to trigger and scale our system. So those are the three key technologies that we use in this project. And then let's take a look more on the solution part. So one component that we wanted to have was a REST API. So at CBS Interactive, I will have this mentality that we want to create services that are independent. So we want to have the services that provide APIs that other teams inside the company can program, can create things or integrate with different services that they have. So we wanted to have a REST API so to be easy to provision. Um, this is Slate Detection. So we decided that the name of the main resource in this API would be a watcher, right? So in the REST API, we would be able to check the status. Like we should be able to check the status of the watcher. So basically, see what's the current video frame that is seen last time, and also we should be able to start and stop the watcher like anytime we want, right? So we don't need to keep this process running all the time. So this is a REST API. It's a stateless API. It's provision the watches using the Kubernetes API, right? And it manages the lifetime of those workers. The worker job is basically what actually receives the RTP feed and is exposed like externally, so we can just grab this RTP, like this URL where we should send out this IP, and then configure one of the propeller channels, right, or any channel that we have like an encoder to send the stream to this worker. And this worker is responsible for one stream. So every different stream, you would run a different process that would watch this stream. We initially, and today we have support for on two containers, like basically the raw video in H264 and MPEG-TS, so you can also send this content. Basically, this is the default that we use in Propeller. So and the raw video I use mostly for like testing locally. So I added the support as well. Just an overview, like how this system fit together. So here at the bottom we have the Kubernetes API, which the Hawkeye API just communicates with this Kubernetes API to provision those different resources. So every worker are composed of three Kubernetes components. So config map with the configuration for the worker, what's the Slate URL, what actions should happen at which moment, retries, things like that. We have the deployment, which is actually what manages the worker itself, like the process. And we have a service in Kubernetes that translates to a AWS load balancer that's exposed externally. And then these components exist for every channel. And the Hawkeye API itself is a different service, different process running that it doesn't need to keep growing, right? So it's just the workers are multiplied by the number of feeds that we need. And then you can see here like the propeller system sending the feed, and then the Hawkeye service triggered the HTTP REST API call that triggered the add feeds. And then it adds the SCARI35 in the schedule of the stream. Like I will show a demo of this. Ideally, we would like to move this inserted break to call directly to the elemental live, so we have more snappy triggering of the ads. Today, this is one of the limitations of the system today, is that since we are not triggering in the elemental live, we are using AWS API in the elemental live to change the schedule of the channel. That sometimes takes longer than we expected. So instead of being like 1 second, it takes like 3 seconds, 4 seconds. So that's not ideal. But as I said, like this is a like flexible enough system that we can change this to call a different API or like directly in the Elemental Live API. So this is one thing that we want to see or we want to change for the future. Just want to show a quick demo. Since this is a, let's say, a thing that depends where the video is playing, right? So it's a live stream. I have actually recorded this happening, like the ad being triggered. So I will show you here. So it's really quick demo, so it won't take long. So here we can see, like we have the propeller uh, dashboard, and here is what the like user that's managing the channel can see. And then we can see here a preview of a live stream, and then it's going to the ad. So you can see that it's showing some partners, it's preparing to go to the ad, and the Hawkeye is running, is listening and watching to this live stream. Then we have the slate, and then after the slate's detected, the advertisements start. So this delay that you see there, that in between the time that the slate appear and the ad played, is what we want to improve more, and that's where we want to call directly the SCAR35 event in the elemental live, and then we could also move the stream in the encoder to be like 1 second earlier to the Hawkeye, and then when we trigger the ad, the user would not, like the people watching would not even see this. Like, so these are a few things that we think that we could improve here to make it more snappy. But yeah, this system works as we expected, and is open source, right? So we have this project available in GitHub. So you can go there and see, like, follow the development. It's a very early project. It's just developed a few days ago, as you can see here. And yeah, there is another image here just showing like how this would grow more, and how to run locally, so you can test and try yourself as well. But that's what I had to show you today. I'm happy to answer any questions or talk to you about the project, and you can ping me in the social media, or yeah, in the video dev Slack, and I'll be happy to discuss. And we accept contributions as well, of course, if you feel like sending.